Hey everyone, Mr. Armitage here, and in this video we are doing something very similar to the previous assignment, but this is assignment for Chapter 4.5 on Big Ideas Online, Finding Zeros. Okay, so exercise 36, it's the fourth problem on the homework. Find all the real zeros of f of x equals x to the third minus 14x squared plus 15x minus 42. Okay, and the zeros are blank, blank, and blank. So we have three zeros that we're going to find. Now, what's another word for zeros? Well, I hope you were thinking solutions, because that is absolutely correct. And it's solutions when f of x equals 0. Okay, so when this function, this polynomial, equals 0. So that's what we need to do. We need to say x cubed minus 14x squared plus 55x minus 42 equals 0. Now, what values of x make this true? I don't know. Do you? Well, let's find out. Okay, let's see, methods that we've used for finding zeros or factoring before. Let's see, we can't use the quadratic formula, right, or the x factor box method, because this isn't a quadratic. Let's see, can we do by greatest common factor? No, there's no common factor for all of them, for all terms. Can we do by grouping? No, not really. Right, there's no real pattern to these coefficients. So we are left with our favorite method, the rational root theorem. So there are two parts to this. First, we need the factors of our constant term, and then we need the factors of our leading coefficient. Okay, factors of 42. Now, I'm not worrying about the positive and the negative right now, but we will need to later. But it's because, positives and negatives can happen a lot. All right, so let's see, 1 times 42 equals 42. Cool. 2 times 21, good. 3 times, why did I blank on that? Okay. 3 times 19. Right? No. 3 times 14. Yes. There we go. Okay, so 3 times 14. Let's see, does 4 go into it? No. Does 5? No. Does 6? Yep. 6 times 7. And at that point, we know there's nothing else to do. Okay. Now let's see, our factors of the leading coefficient. Well, what are the factors of 1? It's just 1. Okay. So this means that taking these two factors, okay, any real solution, any real zero to this polynomial here, x cubed minus 14x squared plus 55x minus 42, will be of the form one of the factors of 42 divided by one of the factors of 1. Now there's only one factor of 1, and when we reduce it, it's going to, right, every solution we get is going to be over 1. right? 1 over 1, 2 over 1, 3 over 1. So every solution is really just going to be one of the factors of 42 in this case. So we know right off the bat, in that way, we can simplify this down. All of our solutions will be, all of the real solutions will be in this list of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 7, plus or minus 14, plus or minus 21, plus or minus 42. Man, I hope that we get a solution before we hit 42. Well, let's go ahead and try it out. Okay, we're going to set up our synthetic division. There we go. Let's hope I don't make any mistakes when we synthetically divide. Okay, so let's put our coefficients in here, which are 1, negative 14, positive 55, and negative 42. 1, negative 14, positive 55, negative 42. So start with the first one. X equals positive 1. X equals negative 1. Okay. So bring down the 1. 1 times 1 is 1. Negative 14 plus 1 is negative 13. Negative 13 times 1 is negative 13. 55 plus a negative 13 is 42. And 42 times 1 is 42, which is 0. Now, isn't that nice? We got a possible root right off the bat. So we can take that positive 1, go back up to the top here. So the zeros are 1. Okay, there's one of them. Now let's find the others. Okay, we could go down this whole list. Right? We could do synthetic division for every single value here. But why would we want to? Okay, we already have this part here, this x equals positive 1, okay, that 0 there, which means that we have a factor of the original polynomial as x minus positive 1 times x squared minus 13x plus 42. Okay, now this is a quadratic. So we can factor this like we would normally. Okay, so let's see, what two numbers, when multiplied together, will give us 42, positive 42, and when added together will give us negative 13. Okay, if they multiply to give us a positive but add to give us a negative, that means we know that they're both negative. Okay, we already have a list of our factors of 42. Let's see. 1 plus 42, or negative 1 plus negative 42, no. Negative 2 plus negative 21, no, negative 23. Negative 3 plus negative 14 would be negative 17, not quite. Must be negative 6 plus negative 7 equals negative 13. Cool. So we can factor x minus 1 times x minus 6 times x minus 7. equals 0. Right, our zero product property lets us take each of these and make them equal to 0, because only one of them has to be 0 for the whole thing to be 0. Nice part about multiplying by 0. X minus 1 equals 0. Well, we already got that, right? That was x equals 1 that we got before. Okay. X minus 6 equals 0. So that's x equals 6. Okay, we can put that one up. We have x minus 7 equals 0. So x equals 7. So we have 6 and 7. There we go. So the zeros are 1, 6, and 7. Now, aren't we glad we didn't keep testing these possible ones here? Right, we would have had to do positive 2 and negative 2, positive 3 and negative 3. And then we would have gotten positive 6, okay, but we would have also had to do negative 6. And then we'd get positive 7. And finally, we'd have all 3. But it was a little easier just, as soon as we got 1, to factor it. Okay. So those are our zeros.